Okay, let's design a switch from some very simple materials. So what we've got are a few paper fasteners and a piece of foam. Now the backing of these circuit boxes is the same foam anyway, polyethylene foam. And it's not that polystyrene foam that shreds into tiny pieces. No, 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 no polystyrene. It's polyethylene. So it's the same material that plastic milk bottles these days are made from. So polyethylene, except this is expanded full of inert gas, and that makes it very good for packaging. So it's packaging foam. So we know that how the switch works. We know that it's got metal contacts inside that can move. Now we're designing our own switch, so we won't need that. We'll still need the light bulb in the circuit to tell us that things are actually working, and we need to sort of have a little operating area where we can work. So let's extend the length of that crocodile by using one more crocodile clip. So let's just check that our light bulb lights up. Yeah, that's fine. There's our two paper clips. And now what we need to do is say, well, how on earth can we make our own switch? So remember, the action of a switch, you've got to be able to press or push something. Press or push something to make the metal contacts touch each other. Well, paper clips are fab for this, because paper fasteners are fabulous for this, because not only can we sort of prong them into things, into the foam, or fit them through a hole in some card, we can also use their springiness. So if I just pull out one of the legs, look, and then press on it, there we are. It's naturally springy. Not particularly strong, but it'll do for what we want to do. So what we could do is say, well, look, let's just keep the two paper clips, paper fasteners, quite close to each other, and now bring in the electrical connections. Let's keep your finger so it stays still. Well, the light bulb hasn't lit up, so no joy there until we bridge the gap. So we could bridge the gap by just pushing the clips together. So let's bring this circuit down a bit. Push the clips together. There we are. Well, one finger perhaps. Yeah. There we go. Well, that's one very simple way to do it. So let's look at an alternative. Let's just take out that one there and put this one in. Push that one all the way in to make a nice firm sort of fixture for it. Now let's just clip this one in, and you'll see what the idea is straight away. We're going to put this one in so that the part that sticks out is over the top of the part that's fixed. Remember, we said switches have a moving contact and a fixed contact. So that's exactly what we've done. There's our fixed contact there that stays in place, and this springy contact is the one that moves. So the insulator, the polyethylene foam, is holding everything in place. So now we just need the other electrical connection. There it is. And then hopefully all we need to do is press on the switch. So let's give it a go. Do it from underneath so you can see. So every time we press on the switch, the light bulb lights up. When we take our finger off, it releases it. So I suppose you could say this type of switch has got a different action to the lever switch we've used earlier. It does not stay pressed. We've got to keep it pressed in order for it to work. Well, we can think our way around that, and we might well be able to change the shape of the clip that's staying still and create a different shape that allows us to say hook it under. So let's just take the clips off for a second. So I wonder if we can just do that. Look, hook it underneath. There we are. So now it's touching, and then when we take it out, it springs apart again. So using the sort of properties of the materials themselves is a great way to help us design switches. So that's our very first switch design. I wonder if you could come up with ideas based on paper clips like this, and perhaps silver paper, no, silver foil, which is aluminium foil really, a special metal aluminium foil, paper clips, and then maybe card or plastic foam. So we've got a design challenge for you coming up after this one, and that's how you're going to use a limited number of materials in order to create a very useful switch. I'll just give you a clue about the switch. We want to be able to send messages with it. What on earth? How on earth could we send a message with the switch?